No kidding.
Yeah. Yeah.
You
Should have.
I got the point.
When
Get a lot of that.
That's true.
You should have. I don't know why you
I was too busy throwing out. I literally threw up in the shower.
Did you eat it?
Okay. Who is missing?
It was one of those things where like you thought you were dying. It was that bad.
Morgan emailed me. She has some kind of flu thing, she said. Okay. Raven.
I feel whole chunks of Campbell's chicken that was sitting up over the weekend.
Okay, like, we're talking about brother, like, he bought me one he does not chew his food because it was like full chunks of chicken. My brother, he did not chew his food that day or something like that. It was just one big ass chunk. Yeah, dude, it was like
How you got a haircut?
not even fully digested.
I like it.
That was clean.
I need to get that done. I can get you some paperwork.
Okay, so here's what we're going to do. We are going to practice real quick for our quiz on Friday. We already did the practice quizzes, right, in the packet? We did those yesterday, I think, didn't we? All right, so let me give you a couple more. And what I'd like you to do is see how many of these you can fill in. I'm going to put like 6 of them up here. But see how many of them you can fill in. Why don't you write these down on your paper? See how many you can fill in without looking at the sheet. Without looking at the sheet. See how many of them you can fill in.
Bless you.
Alright, see how many of those you can fill in real quick. We're only going to take minutes to do this. Take just a minute to get these done. Any paper, just a notebook paper or the back of something, but try not to use your green sheet, alright? We're trying real hard not to use our green sheet.
It's gonna be a challenge.
It's going to be a challenge. Indeed. Another piece of paper, yep. It can be a scrap piece of paper, you're not turning it in. This is just to see how much you know and what you still need to memorize. Joseph John, really don't want to be trash talking on the tape.
Getting sport.
I know. I have to.
It seems like you're kind of trash talking on tape sometimes.
Well, you guys deserve it.
Is this without looking at the sheet?
Yeah, without looking at the sheet, but we're going to be down here in just a second. Trey, why are you walking around?
No, I don't think it doesn't go away.
Okay, well now you're done, so sit down. Here we go. Let's see what you knew. Anybody know the first one without looking at the green sheet?
Cosine.
That is cosine squared. Make sure you put the squared on it, and make sure you attach the x. Sine squared plus cosine squared is 1. It would be a shame to, know there's supposed to be something with cosine in there, but not do it right. So make sure you do cosine squared. All right, how about this one? It is negative tangent. remember, we talked about this, that every single one of the functions, all 6 of them, if you put a negative in here, a negative is gonna come out, except for 2. What are the 2 where the negative just disappears? Cosine and secant. Everything else, if there's a negative in here, it shows up out here. Got it? Alright, what's cotangent? Look, that's something over something. What is it? Cosine over sine. Very, very good, Deshaun. One of your reciprocal identities, cosine over sine. Alright, 1 plus tangent squared. Anybody remember that one?
Is it cotangent squared? Oh,
No,
wait, no.
it
Never
is
mind.
secant squared.
I tried it.
It is secant squared. So make sure you have the squared, make sure you have the x or the theta or the whatever the variable is. Secant equals 1 over cosine. Anybody who misses this one is really in trouble because we've been using that a lot for a long time, since Christmas basically. What was the question?
Is you said theta was the same thing as x?
Yes, so you're allowed to use x if you want.
Oh, cool.
How about this one? Uh-oh, it's got a 90 in it. What did I tell you about the 90s? They are complementary. CO. What's the co-function for cosine? Sine. This is sine theta. Anytime you see a 90, it's the co-function. And the co-function is the co of the one dot. So you got cosine, sine. Cotangent, tangent. Cosecant, secant. Samantha.
Could the bottom one on the left side, could that also be 1 over tangent?
It absolutely could be 1 over tangent. Cotangent and tangent have a couple of different definitions, and yes, it could be either one of those. Okay, tomorrow is the day, or Friday.
I was like, okay.
I don't have any. Next time I see you, we're gonna be doing that, all right? It's gonna be like that. Okay, so now we're getting out our
Something to get cute.
packet. And we are going to look at more practice problems of these simplification kinds. Yesterday, did I stop? Okay, so I stopped at 6? All right. So we're going to get ready for 7. Tomorrow's quiz is over this. The next quiz we have will be like the problems we're practicing, which are using all of these things. Tomorrow's quiz is just memorizing. Friday's quiz. Just memorizing. All right, so let's look at number 7. You guys think I'm like deaf? Like I don't know every time I turn my back. You're like acting like idiots. Yeah, they are.
They didn't catch his attention.
I'm just saying that. When I get on video. All right, here we go. Anybody have an idea how we would start this? Your job is to simplify it. So it's a big mess. So what's a thought you have to simplify it?
Take an X out.
Okay, now, let's talk about that. You cannot separate the x from the function. So sine x is an unbreakable unit. It's like saran wrapped. These are saran wrapped together. You can't split them up. All right, so it's an idea, but can't do it. Anywhere the sign goes, its x is going with it. So I could, if this had been a sine x, I could take the whole thing out, the whole sine x out. But it's not. What about tangent?
Did you?
Tell me about tangent. It is, Jonathan. So I have sine, oh, that's just sine over 1. And this is sine over cosine plus cosine. Now these are times together. So what does that give me when I time, or when I multiply them together? What do I have? Sine squared over cosine.
Alright.
Top times top, bottom times bottom. Everybody good? Plus cosine over 1. Just plain cosine. These are fractions added together. How do I add fractions together? Get a common denominator. So this one's got a cosine, this one doesn't. So let's give this one a cosine.
I have a question.
Yep.
Wouldn't both the cosines just cancel?
Not when they're added. If they were multiplied, yes, but when they're added, no. Think of it like this, Marley. If you had 2/3 plus 3/4 with a plus there, you wouldn't do that, would you? That was added. So when you're adding, the rules are different. If I were multiplying, absolutely I could cancel that.
Okay.
But I'm adding. Alright, so I gave, this fraction already has a cosine in the bottom. I gave this one a cosine in the bottom. So now, do the denominators match? They're both cosine. So I'm going to write one fraction and the denominator's cosine. Now what's the numerator? Well, what's this? Sine squared plus, oh my gosh, look, I'm trembling. Sine squared plus cosine squared. What is that?
1.
That's 1. So now I have 1 over cosine, which is the same as secant. So you took this big mess right here, and using your identities, you were able to simplify it all the way down to secant. Now, I know some of you are thinking, I'm never going to be able to do this on my own. Yes, you will. Yes, you will. It's all about practice. Practice, practice, practice. All right, that was 7. Let's look at 8.
I just want to
Cotangent sine plus tangent cosine. What do you think? Any ideas? Any thoughts?
You do 1 over or sine over
Okay.
or cosine.
Yes, you can either one, and the smartest one, since the problem already has a sign in it, would be to do cosine over sine. That's the smartest one, because I can do in a couple hours. I need to hydrate.
Need some water.
I really do. Cosine over sine times sine over 1. Now, what's going to happen, Marley? You see this is a multiplication problem, so now we can cancel. So that, this side just came out to be cosine. That's all that's left. Now, what do you think we're going to do over there?
How do you get the cosine over sine?
That's what cotangent is.
Sine over
That's what
cosine.
cotangent is. So I'm going to take that tangent and I'm going to do the same thing. I'm going to write it as sine over cosine. And it is being times by cosine. Well, what's going to happen? Same thing. Those are going to cancel, and I'm left with plus sine. Oh, nope, it's not 1. I knew somebody would say that, and that's okay. But what do I not have that I need? I don't have a square. If they're not squared, then you're just done. Cosine plus sine. But remember, this is what you started with. Isn't that a lot better than what you started with? Yeah. A lot easier to work with. What?
No, I was singing a song. Sorry.
Okay, it's all right. Okay, so now we're looking at number 9. Cosine 1 plus tangent squared. Now, all the little beepers are going off in my head as I wrote this problem down. 1 plus tangent squared. That's secant squared. So this guy right here is on my green sheet. It says secant squared. Now what do you think? There's one more step to this.
1 over secant.
Cosine is 1 over secant. What's going to happen since I am multiplying 1 over secant times secant squared? It's a multiply, so what am I going to be able to do? Cancel, and all I'm going to be left with is 1 little secant. So look at what you started with, big mess, and using your identities, you got it whittled down to this. Yep, Marley.
Why'd you take the secant squared, like the 2 away?
Because I canceled it with this was 1 over secant. So I have 1 secant on the bottom and 2 on the top. So it's like having x squared over x. You can cancel this guy into here, but it leaves an x on top. Because you had 2 secants on the top, squared, 2 of them, but 1 of them canceled out. So that left you with just 1 left. Oh, you're starting to get the hang of it, aren't you? Oh, look at number 10. Any idea? I heard somebody say it. I heard somebody say something.
Sine over cosine.
Tangent squared is sine squared. Now here, big fraction. This part right here is sine squared over cosine squared. And that's over this. And what's this? 1 over cosine squared. Now, what do I do when I have a big fraction like this? Can I,
Oh, you find the
what would the common denominator be, Deshani?
cosine.
Cosine squared. So you can either do it that way, or you can say, all right, this is sine squared over cosine squared divided by 1 over cosine squared. And what do I do when I divide by a fraction? I flip it. And which one do I flip? The second one. Always the second one. So it's going to be sine squared over cosine squared times cosine squared over 1.
So you do sine over 1.
So the answer would be sine squared over 1. And you don't even have to write the over 1. You can just write plain sine squared. It's not wrong if you put it over 1, but you don't have to. We're making good progress. You're doing a good job. It's the last one on this page. We're flying. What do you think? Do you notice anything? There's, Colleen, 2 sine squareds. So there's a sine squared here, and there's a sine squared over here. What could we do? Factor them out? Combine them? Pull it out? So if I pull out the sine squared, what will I have left? I'm taking out the sine squares. So what will I have left when I do that? Secant squared minus 1. Okay, Colleen's got the right idea. She's looking at that green sheet. She says, I know there's something that's got secant squares and 1s in it. It is, you gotta be careful, the identity says 1 plus tangent squared is secant squared. That's what we memorized. If we wanted to rearrange it, could we move this 1 to the other side?
Yeah.
And if we did that, what would it say now if I subtracted that 1 over to the other side? Now it would say tangent squared equals secant squared minus 1. Which means that anytime I see a secant squared minus 1, I can plug in a tangent squared.
Yep.
So I have sine squared, tangent squared. Is that okay? Now, you can leave it like this, or you could take it one step farther, which isn't going to make it any simpler, and change tangent squared into sine squared over cosine squared. Then you'd end up with sine to the 4th over cosine squared.
We can
So,
just leave it like that.
or you can leave it just like this. Yep.
But if we do it the other way too.
And you could do this and leave it like this. Whatever way you think looks best or simplest to you. These are a little bit tricky because you never quite know when you're supposed to stop. I get that. I get that. All right, am I ready now for the next page? Oh, I think we did something like this yesterday. Does that look at all familiar? Not this exact problem, but does anything occur to you when you look at this? Well, I can't cancel until, anytime there's pluses and minuses in the problem, you can't cancel until you factor. Can we factor? Well, how does the top factor? It's perfect squares.
X minus 2.
So the top is going to be cosine x minus 2, cosine x plus 2. The top is what we call the difference of squares. It's a squared minus a squared. So it's a plus b, a minus b. Cosine minus 2, cosine plus 2. Now, the bottom does not factor because it is not squares, but what you notice, you can cancel. So the answer ends up being just cosine x plus 2. Yeah, I'm gonna come and carry you home.
Giddy.
You know what that means, right? All right.
Oh.
I didn't tell her that. I'm probably glad I didn't.
Am I allowed to use the restroom?
No.
Like really quickly?
What do you need to do that for?
What do you mean?
Why didn't you want
Because I didn't have to use the restroom.
All right, when I look at this problem, it looks very similar to one I just erased. When I see a 1 minus sine squared, exactly. 1 minus sine squared is cosine squared. Now, I asked you to write that on your green sheet. You have an identity that says sine squared plus cosine squared is 1. If we move the sine squared to the other side, then that identity says cosine squared equals 1 minus sine squared. If you haven't added that to your green sheet, you need to do it. We use that one a lot. Anytime you see a 1 minus sine squared, you're allowed to write it as a cosine squared. All right, I don't think we're done. What do you know about secant squared? It's 1 over cosine squared. Now what happens when we take 1 over cosine squared and times it by cosine squared over 1? It all cancels out and leaves me with 1. So who knew that that answer, or that question right there, was gonna boil down to what? Robbie, was there an important message on your phone?
Four.
No.
Four.
Yeah,
So on that one, did the secant squared turn into 1 over cosine?
it did. Because secant, regular secant is 1 over cosine. So secant squared is 1 over cosine squared.
Okay.
Marley?
In the problem before, number 12, the final answer was cosine.
What?
The final answer was cosine x plus 2.
Uh-huh.
But why couldn't you, like, do 1 over secant plus 2?
You absolutely could, but here's the question. Is it simpler to have plain cosine, or is it simpler to have 1 over secant? Probably plain cosine. And our job is to simplify. So if you did that, it would not be wrong. It just is kind of an extra step that makes it worse than it was before. Our job is to hopefully take big things and make them small, not make them bigger once we made them smaller. Okay? But you're right, it could be. Absolutely could be.
Yeah.
All right, we're gonna finish these problems. So here we go. You got cosecant tangent plus secant. All right, I heard somebody say 1 over sine and sine over cosine. So cosecant is 1 over sine. Tangent is sine over cosine. And we might as well do secant while we're at it. What's that? 1 over cosine. Now, this is a plus sign, so there's going to be no canceling here. But these are times. Can we cancel these?
Yeah.
So we have, what are we going to have? 1 over cosine plus another 1 over cosine. Now, if you want to, you could think of this as secant, and this is secant. Would you agree with that? Maybe it's easier to do it that way? And what's a secant plus a secant?
2 squared.
No,
Oh,
not
twin.
6 squared, you're adding. So 1 secant and 1 secant would be 2 secant. Or, if you did it back here, it would be 2 over cosine. 1 over cosine and 1 over cosine would be 2 over cosine. So you could either write it this way or this way. Makes no difference. Kind of like Marley's question a minute ago.
This might be exactly like the last question I asked, but for tan, couldn't you do 1 over cotangent?
You could. Here's the thing about 1 over cotangent though. It isn't going to match up with the other terms in the problem, so there won't be any chance of canceling. So it wouldn't be a wrong move, it just kind of gets us nowhere.
Okay.
You see what I'm saying? Our goal is to make things cancel out, and tangents and sines and cosines don't cancel out. But if you change the tangent to sine over cosine, then you got a chance. Or the cotangent to cosine over sine. Which one is that? That was 14. All right, how about 15? Oh, we've seen this kind before. Oh. Okay, I hear 2 great ideas. One idea is to factor this. Another idea is to change the cosecant into 1 over sine squared. Now, there is no right answer. Those are both wonderful options. I'm going to do it both ways and show you how both options work. If we factor, we would have what? If we factored out a sine squared, we'd have cosine squared minus 1. Now, did I say cosine? I meant cosecant. We'd have cosecant squared minus 1. Now, I know there's an identity that has a cosecant squared and a 1 in it. I always have to write it down. 1 plus cotangent squared is cosecant squared. So if I move the 1 over here, so I have cosecant squared minus 1, what's that going to equal? Move that over. What's cosecant squared minus 1 going to equal? Cotangent squared. So I'm going to replace this with cotangent squared. That's what it equals. Now what's cotangent squared?
Cosine over sine.
Cosine squared over sine squared. So now I have sine squared times cosine squared over sine squared.
You cancel the signs.
The sines are going to cancel, and the answer is cosine squared. Now that's one option, all right? So we're going to do it the other way in a minute. Robbie?
Could you square root everything?
No, that's not allowed. It's like if you're walking down the hallway and you find a 9, and you say, I don't like 9s, I think I'll just square root it. Can't do that, because that gives you an entirely different number. That gives you a 3. We got to keep what we have there, so no, we can't. Alright, so let's go back to the original problem, and let's look at the other idea somebody had, which was change this into 1 over sine squared. You can do that. I mean, it's true. What happens if you do that? They cancel, and you're left with 1 minus sine squared. Look on your green sheet. What's 1 minus sine squared? Cosine squared. So it doesn't matter which route you take, you end up at the same place. Just depends what makes sense to you.
Could you do, like for sine squared, could you do 1 over cosecant squared?
You absolutely could. Yep. And then the cosecants cancel, and you're still left with 1 minus cosine squared. Absolutely. So that, or 1 minus sine squared. That would be another way of doing it. So now we've looked at 3, or talked about 3 ways to do this problem, and there are probably a whole bunch more. So the nice part of this is you get to do it however it makes sense to you. 2 more, you guys. We got to get through 2 more. All right, what do you think about this? Oh, no. Let's talk about that. There's definitely some squaring going on, but how are we going to do it? It's a FOIL problem. This is sine plus cosine times sine plus cosine. This is a FOIL problem. Alright, so here we go. Here we go. Let's FOIL. What's first times first? Sine squared. Yep. Outsides. Sine x, cosine x times each other. We're multiplying. What's inside? Cosine x, sine x. And what are the lasts? They'll give us. Cosine squared. Alright, what a mess. We're supposed to be simplifying, and that was worse.
Boy, tell me about it.
Yep. What do you notice about it, input? What do you mean you can group?
Put them together so you get 2.
So you get 2. Is this what you're saying, Joseph? These 2 match? Those guys match. So instead of having 1 sine cosine and another sine cosine, I have 2 sine cosine. What about the things on the end? Liam? Yes, it does. Sine squared plus cosine squared is 1. So those 2 add up to give you a 1, and the other 2 don't cancel or anything, they just add up to give you 2 of them. One more. What do you think we're gonna do with number
Uno más,
17? Foil it. Foil it. Alright, so you give it a shot on your paper, I'll give it a shot up here, and let's see if we can end up with the same foiling. I did first outside, inside last. Tell me what. What do you think about my foiling? Does it look okay?
Yeah.
Do you notice anything?
The middle two.
Oh, the middle two this time canceled. Last time they were both pluses, so we had to add them together, but this time we have a plus and a minus, so they're gone. Right, now wait a minute. Do I have an identity that's got cotangent squares in it?
Yeah. Yes.
I'm gonna write it down over here at the side. 1 plus cotangent squared equals cosecant squared. Will that help me at all?
What about the other one?
What do you mean the other one?
The one that you told us right under that one?
Oh, maybe cotangent squared equals cosecant squared minus 1, that one? So, could I take that cotangent squared, Jonathan,
Yeah.
and replace it with cosecant squared minus 1?
Yep.
And then I have my minus cosecant squared down there on the end? So you just get -1. So that mess simplified all the way down to -1. Alright, that's the hardest thing I think we're gonna do this year. And we'll be having a quiz over that, not Friday, but probably Monday. So I want to practice a little bit, let you practice with a partner. In the packet I gave you that had the memorization quizzes on the front. On the back side of that, it says extra practice 5.1. See it?
Mm-hmm.
Now what I want you to do is I want you to find somebody to work with, and I want you, and it can be 2 or 3, all right, groups of 2 or 3, and we're focused, all right? And I want you to find on here 3 problems, pick any 3 that look like, oh, I think I have an idea for that one, I think I can do it. See if you can find 3 problems that you can do, and then we're gonna put them up on the board.
The practice quiz?
No. We're on the back of the memorization quizzes, it says extra practice 5.1. There's 23 problems there. Pick 3 of them that you think you can do.
On the back of the memory.
Yep.
I got
The
you.
back of the memory.
Wait, am I hitting this?
You're hitting it.